So far we've been taking care of derivatives that have been polynomials. The first one was x cubed, the second one was 6x plus 7, the third one was another cubic polynomial that had a lot of terms in it. But the derivative works for any function, okay, including a function like the square root of x, which is our third example. In taking a look at this one, we have to do a little bit more than just expanding polynomials. We have these radicals that we have to deal with. All right, so what we have again is the limit of our difference quotient for our derivative. We're going to plug x plus h into our function. That gives us the square root of x plus h minus the square root of x all over h. Okay, but where do we go from here? All right, and again, we're going back on our pre-calculus knowledge. If we're trying to simplify a square root, well, the initial thought is, well, let's square it. Well, we can't square it because of this difference right here. It's not going to make the square roots go away. And in addition to that, we have to square the other side of the equation, which means we have f prime squared. We don't want that when that brings in potential other answers. We need to work another way around it. And that other way is to multiply by 1, just in a version that works for us. You've done this in pre-calculus, all right? What we have here is we're going to multiply by the square root of x plus h plus the square root of x over itself. Any number divided by itself is 1. So what we did here, what I just wrote in black, is just multiplying by 1. It's just a version of 1 that's going to help us out. Because now we have 2 terms in the numerator and 2 terms in the numerator. And if we multiply them, we multiply these 2 fractions, we know we do numerator times numerator and denominator times denominator. Watch what happens when we do the numerator times the numerator. So we have this term, and we have to multiply it by both terms. For the second numerator, the square root of x plus h times the square root of x plus h. All right, well, think about that for a second. If I asked you for the square root of 5 times the square root of 5, well, that would just be 5. So the square root of x plus h times itself is going to just be x plus h. So we have the limit as h approaches 0, and in our numerator we have x plus h for the first part. Now we go to our outer terms. Outer x plus h under the radical times radical x. So that means that we have, and it's positive, notice. So it means we have plus the square root of x times x plus h. For foiling here, we now go to inner. That means we're going to have the opposite of the square root of x times the square root of x plus h, which means we have this exact same term, except it's negative. So negative x times x plus h under the radical. And then finally, with last, the square root of x, which is negative, times the square root of x, which is positive, that gives us minus x. The square roots cancel each other out. That's all over h. What happens with those 2 terms in the middle? Yeah, they cancel, exactly. This is positive, this is negative, otherwise they're identical. So they wipe each other out. Okay. Not only do they wipe each other out, but we also know from previous problems that any non-h terms should cancel each other out. And in fact, we have an x here and an x there. So they cancel each other out. So look at all that stuff that's happening in the numerator. Okay. Now what we've got to be careful of in the denominator is we don't just have h anymore. Remember, we multiplied in the numerator. We also have to multiply in the denominator. H times this. So we have the h right there, but we also have, and I'm going to put in parentheses to keep it together, the square root of x plus h plus the square root of x. Okay, that's there as well. You're thinking, well, that's a pretty messy denominator. That's okay. Okay, because ultimately our goal is to get rid of this h. And look what we can do. We only have h left in the numerator. So those h's will now cross out. H divided by h is 1. So what are we left with? We're left with the limit as h approaches 0 of 1 over square root of x plus h plus square root of x. We plug in 0 for h, so we have 1 over the square root of x plus the square root of x, which is a great answer, or if you want to simplify it, that's 1 over 2 square roots of x. This is the derivative of the square root of x. It's a lot of work, it's a lot of knowledge from pre-calculus that we have to remember to come up with that solution. So I wonder if there's an easier way to go about it that might also be quicker. That's where we're heading. If we take a look at example 4, now we have the derivative of a rational function. That's going to take a lot of time and effort as well. It'd be nice if we can avoid these. And this leads us into the next video which talks about how we have some rules for differentiation.